Hello students, welcome you all to the next module, module 4, infinite series and power series solutions of your subject 18MAT21, advanced calculus and numerical methods. So in this module has been divided into two parts. The first part is infinite series and the second part is power series solution. So today in this video session I am going to discuss about the first part, that is infinite series. An ordered set of real numbers u1, u2, u3, u4, etc. un is called as a sequence and it is denoted by the set un. An ordered set of real numbers. A set of real numbers in this order is regarded as a sequence and we use this notation to denote that particular sequence. This notation is read by sequence un, that is u1, u2, etc. un. For example, you have 1, 3, 5, 7, etc. 2n minus 1 and 1, 1 by 2, 1 by 3, 1 by 4, etc. 1 by n. 1 minus 1, 1 minus 1, so on, etc. sequences. You can see here, this is not finite, it goes on continuing. So these type of sequences are known as infinite sequences. Now, if a sequence un has a finite limit, then it is called a convergent sequence. If the limit of the sequence un is finite, then it is called a convergent sequence. Otherwise, it is known as a divergent sequence. For example, in this examples, 2 is convergent. 1, 1 by 2, 1 by 3, etc. 1 by n and so on. As n tending to infinity, what is 1 by n? 1 by n becomes 1 by infinity, that is 0, a finite limit. So it is convergent, while 1 and 3 are divergent. It goes on increasing, it do not stop, it is divergent. Now what is a series? If un is a function of n defined for all integral values of n, an expression of the form u1 plus u2 plus u3 plus etc. un plus so on containing infinite number of terms is called an infinite series. un is a function of n. So now an expression of the form u1 plus u2 plus u3 plus etc. un plus so on containing infinite number of terms. So in this summation there are infinite number of terms and this summation is regarded as infinite series and it is denoted by summation un, n varying from 1 to infinity. Summation short notation is summation un, n varying from 1 to infinity, that is u1 plus u2 plus u3 plus etc. It goes on up to infinity. And here un, generally un is called the nth term or the general terms of the series. u1 stand for the first term, u2 second term and so on. The sum of n terms of the series is denoted by Sn. The sum of the first n terms of the series is denoted by Sn. So Sn is u1 plus u2 plus u3 etc. plus un. Now what is convergent and divergence of a series? A series sigma un is said to be convergent if limit n tending to infinity Sn is equal to L, a fixed number. And if the limit is infinite, it is known to be divergent. If the limit n tending to infinity of Sn is a finite number, the series is known as convergent, otherwise it is divergent. So I have given one example here, geometric series as an example for convergence and divergence. And the geometric series is convergent for mod r less than 1, Remember this derivation is not needed. Geometric series is convergent for mod r less than 1. The geometric series of the form a plus ar square, etc. This type of series is known as geometric series. And it is divergent for r greater than 1. So find, and r equal to 1 also it is divergent. So geometric series is convergent if r less than 1 and divergent if r greater than 1. So in this video session we will be studying about two types of test, Cauchy's root test and D'Alembert's root test, to check the convergence or divergence of the series. Now what is Cauchy's root test? If summation un is a series of positive terms and if limit n tending to infinity un to the power 1 by n is a finite number, then the series is convergent if L less than 1, divergent if L greater than 1, and the test fails if L is equal to 1. So remember, you have a series sigma un of positive terms and you find the limit of un to the power 1 by n as n tending to infinity. Suppose it is equal to L, then the series is convergent if L less than 1, divergent if L greater than 1, and this test, Cauchy's root test, fails if L equal to 1. So if L equal to 1, using Cauchy's root test you cannot decide about the convergence and divergence of the series. So note, the test is applicable if un is of this form, f of n to the power some power function. Limit n tending to infinity n raised to 1 by n is equal to 1. Make a note of this. And limit n tending to infinity 1 plus 1 by n to the power n is equal to n. Make a note of this limit. It is used while solving the problems. Okay, first I have considered a simple example here. Test the convergence for summation n cube by 3 to the power n. This is of the form summation un. So what is your un? N cube by 3 to the power n. Find the limit un to the power 1 by n as n tending to infinity. Limit un to the power 1 by n as n tending to infinity. Un is n cube by 3 to the power n to the power 1 by n. So n cube to the power 1 by n, that becomes n to the power 3 by n, divided by 3 power n to the power 1 by n. So n cancels with 1 by n, you will get only 3. So this can be written as limit n tending to infinity n to the power 1 by n whole to the power 3. Numerator n to the power 3 by n, you rewrite it as n to the power 1 by n to the power 3 divided by 3. What is the limit of this term? Just now I told you, that is 1. So it is 1 to the power 3, that is 1 by 3. Okay. Now what is Cauchy's root test? If limit n tending to infinity un power 1 by n is equal to L, and if L less than 1, the series converges. So this 1 by 3, it is less than 1. So the series converges by using Cauchy's root test. So take one more problem. Test the convergence for summation 1 plus 1 by n to the power n square. So un, this is your un. What is un to the power 1 by n? You can directly find here or find this separately. Un to the power 1 by n. 1 plus 1 by n to the power n square, that is un to the power 1 by n. So n square into 1 by n. So this is n. So power becomes n. So limit n tending to infinity un power 1 by n. Limit n tending to infinity 1 plus 1 by n to the power n. Right? What is the limit of this? I had given in the note. The value of this is e. that is e to the power 1, and the value of e to the power 1 you can find using calculator, it is 2.7. So use Cauchy's root test. This value is greater than 1, limit n tending to infinity, un power 1 by n is greater than 1. So summation un is divergence. The series is divergent by Cauchy's root test. One more example you have here. Summation n is equal to 1 to infinity n plus 1 by n whole to the power n square into 1 by 3. So un I have written here. You can further simplify n plus 1 by n. What is n plus 1 by n? N plus 1 by n can be written as 1 plus 1 by n. Right? I have rewritten n by n, that is 1 plus 1 by n. So 1 plus 1 by n to the power n square into 1 by 3 to the power n. So find un to the power 1 by n. 1 plus 1 by n to the power n square to the power 1 by n divided by 3 to the power n to the power 1 by n. Right? Raise the numerator to the power 1 by n, denominator to the power 1 by n. So 1 plus 1 by n to the power n square into 1 by n. So 1 n get cancels. 1 plus 1 by n to the power n. Right? Denominator n get cancels. 3 to the power n, that is simply 3. So find the limit of this as n tending to infinity. Limit n tending to infinity un to the power 1 by n. Limit n tending to infinity. What is un to the power 1 by n? Substitute 1 plus 1 by n to the power n divided by 3. But this is the standard limit as I have given in the note. You have used in the previous problem also. This value is e by 3. E is near equal to 2.7 by 2.7 divided by 3. So it is less than 1. So the value of the limit is less than 1 by Cauchy's root test. Summation un is convergent. You have one more problem here, then we will go to the next test. Test the convergence for summation 1 plus 1 by root n to the power minus n to the power 3 by 2. So un is 1 plus 1 by root n to the power minus n raised to 3 by 2. So what is un to the power 1 by n? You can observe here 1 plus 1 by root n to the power minus n to the power 3 by 2 into 1 by n. N to the power 3 by 2, 1 by n is n to the power minus half. So n to the power 3 by 2 into n to the power half. So that is n to the power 3 by 2 minus half, that is n. Right? Sorry, this is not half, this is 1. N to the power minus 1. 1 by n is n to the power minus 1. So n to the power 3 by 2 into n to the power minus 1. That is n to the power half. So 1 plus 1 by root n to the power minus n to the power half, or minus n to the power half is root n. So un to the power 1 by n is 1 plus 1 by root n to the power minus root n. So find the limit of this term as n tending to infinity. Limit n tending to infinity of 1 plus 1 by root n to the power minus root n. Or this minus power, since the power is minus, you can get the term to the denominator. 1 plus 1 by root n to the power root n. And this limit is also equal to e as n tending to infinity of the form 1 plus 1 by n to the power n. Instead of n, you have root n. So this is also e. So it becomes 1 by e, which is less than 1. Okay. So limit un to the power 1 by n is also less than 1. So by Cauchy's root test, the series is convergent. Okay, you can work out the similar problems on this topic. I'll give you few examples for D'Alembert's. First, I'll explain you what is D'Alembert's ratio test, or simply it is known as ratio test. Then we shall move on to the problems. So here, if summation un is an infinite series of positive terms, and if limit n tending to infinity un plus 1 by un is equal to L, then the series is convergent if L less than 1, divergent if L greater than 1, and test fails if L equal to 1. So you can observe here, there in Cauchy's root test you had to find the power limit n tending to infinity un to the power 1 by n, but here you are finding the limit of the ratio of two terms un plus 1 by un, and the method of testing for convergence and divergence is the same. If this L is less than 1, convergent, L greater than 1, the series divergent, and L equal to 1, the test phase. But you are finding the limit of un plus 1 and un. Limit of un plus 1 by un. So we shall take a few problems. Test the convergence for the following: 1 square by 2 plus 2 square by 2 square plus 3 square by 2 cube plus 4 square by 2 power 4, and so on. So here it is not given in the form of summation un. So you have to write the general term. So you can observe here, numerator is 1 square, 2 square, 3 square, 4 square. So when it comes to the general term, what will be your numerator? N square, right? N equal to 1, it is 1 square. Second term 2 square, 3 square, 4 square. So in general it will be n square. And denominator you can observe 2, 2 square, 2 cube, 2 to the power 4. So generally it will be 2 power n. So you have un. What will be your un plus 1? N plus 1 whole square divided by 2 to the power n plus 1. That is obtained by changing n to n plus 1. Okay. Now find un plus 1 by un. Un plus 1, n plus 1 whole square divided by 2 to the power n plus 1 divided by un divided by n square into 2 to the power n, or into 2 to the power n by n square. Fine? Into 2 to the power n by n square. So you can observe here 2 to the power n by 2 to the power n plus 1. Here 1 power extra for 2. So 1 and 2 remains. Right? So 1 by 2, n plus 1 whole square by n square. You are written as it is. Now find the limit of this term. Limit of un plus 1 by un as n tending to infinity. 1 by 2 you write as it is. N into 1 plus 1 by n. This term you have here. N plus 1 whole square. So I have taken n outside here. When I take n outside, it becomes n square. 1 plus 1 by n whole square. If you take n outside, remaining is 1 plus 1 by n whole square. That is what I have written here. You can observe 1 plus 1 by n whole square. So n square get cancels. Half into 1 plus 1 by n whole square. As n tending to infinity, what is 1 by n? 1 by n is 1 by infinity, becomes 0. So half into 1, that is half, which is less than 1. So what is your conclusion? By ratio test, the series is convergent. Test the convergence for the following: summation n factorial divided by n raised to n to the power 2. So un you have directly here. Un is equal to n factorial by n raised to n whole square. So what is un plus 1? Replace n by n plus 1. N plus 1 factorial divided by n plus 1 to the power n plus 1 whole square. So limit n tending to infinity un by un plus 1. Limit n tending to infinity n factorial by n raised to 2n into n plus 1 to the power 2 into n plus 1 divided by n plus 1. Right? Now this n factorial by n plus 1 factorial, that is n, right? Sorry, n plus 1. N factorial by n plus 1 is, n plus 1 factorial is only 1 by n plus 1. So that n plus 1, n plus 1 get cancels. You are left here with n plus 1 to the power 2n plus 1 divided by n to the power 2n. Right? So this can be written as n plus 1 by n whole to the power 2n into n plus 1. One more n plus 1 term. So now if you take here n out, this can be written as n into 1 plus 1 by n. So 1 n get cancels. 1 plus 1 by n to the power 2n, or 1 plus 1 by n to the power n whole to the power 2 into n plus 1. So that is, this term is e. Right? This term is e into n plus 1. As n tending to infinity, e into n plus 1 tends to infinity. So you can observe here, instead of limit un plus 1 by un, I have considered limit un by un plus 1. So if you consider limit un plus 1 by un, this will be equal to 0, a finite limit which is less than 1. So the series is convergent. You have one more problem here. Test the convergence for the following: 1 plus 2 factorial by 2 square plus 3 factorial by 3 cube, 4 factorial by 4 to the power 4. By seeing the series, you need to write down the nth term. 2 factorial, 3 factorial, 4 factorial. So what will be your numerator? N factorial. And the denominator is 2 square, 3 cube, 4 to the power 4. Denominator will be n to the power n. So again here you can consider un plus 1 by un, limit n tending to infinity un plus 1 by un. What is limit of n tending to infinity un plus 1 by un? You will get it as 1 by 1 plus 1 by n to the power n. That is 1 by e, which is less than 1. So the series is convergent. I can help you with the simplification here. Un is n factorial by n to the power n. Un plus 1. N plus 1 to the power n plus 1 divided by n plus 1 factorial. Again here n factorial by n plus 1 factorial is n plus 1. So n plus 1 to the power n plus 1 by n plus 1 is n plus 1 to the power n. So n plus 1 to the power n by n to the power n. That is 1 plus 1 by n to the power n. This is un by un plus 1. You can find this, or you can go for limit of un plus 1 by un. You will get it as 1 by e, which is less than 1. So the series is convergent. Okay, you have one more problem. Test the convergence for the following: x by 1 into 2 plus x square by 2 into 3 plus x cube by 3 into 4, and so on. So you can observe x to the power 1, x square, x cube. So numerator will be x to the power n. Denominator 1 into 2, 2 into 3, 3 into 4. So what will be your nth term? N into n plus 1. So what is un plus 1? X to the power n plus 1 divided by n plus 1 into n plus 2. So find un plus 1 by un. X to the power n plus 1 divided by n plus 1 into n plus 2 divided by un, or into n into n plus 1 by x power n. So n plus 1 get cancels. N by n plus 2 into x. So un plus 1 by un is n by n plus 2 into x. So find the limit of this as n tending to infinity. Limit n tending to infinity un plus 1 by un is equal to limit n tending to infinity n by n plus 2 into x. So here if you take n out in the denominator, n into 1 plus 2 by n, right? So n get cancels. Whatever n you have taken out get cancels. So 1 plus 2 by n, 1 by 1 plus 2 by n into x. As n tending to infinity, what is 2 by n? 0. So 1 by 1, that is 1 into x. As n tending to infinity, this value will be x. So according to D'Alembert's ratio test, the series sigma un is convergent if this x is less than 1 and divergent if x is greater than 1, and the test fails if x equal to 1. Test the convergence for the following. So here I have written omitting the first term because you can observe here x is not there, right? In all the terms you have x, so you can omit the first term. When you have infinite number of terms, if you omit the first term, it doesn't make much difference in the series. So you can treat this as the first term, this as the second term, and so on. So if you do like that, what will be un? The first term you can see x square, second term 4, third term 6 power, and so on. So what will be the power of the nth term? For x to the power 2n. And you can observe here, first term you have 3, second term 4. So what will be your nth term? N plus 2 into root n plus 1. Verify this. So replacing n by n plus 1, what is un plus 1? X to the power 2n plus 2 divided by n plus 3 into root of n plus 2. Write un plus 1 by un. Un plus 1 is x to the power 2n plus 2 divided by n plus 3 into root n plus 2 by un, or into n plus 2 root n plus 1 by x power n. So cancel the terms whichever possible. You have n plus 2 by root n plus 2 into root n plus 1, n plus 3 root n plus 2. Here x to the power 2n plus 2 by x to the power 2n. So only x square remains. Find the limit of this term as n tending to infinity. Limit n tending to infinity un plus 1 by un. So as n tending to infinity, what you do is you can take n outside to find the limit. N if you take outside, this will be 1 plus 2 by n, and this will be 1 plus 3 by n. So that n get cancels from the numerator and denominator. Here also root n, 1 plus 1 by n, 1 plus 2 by n into x square. As n tending to infinity, what is the value? This 2 by n becomes 0, 3 by n is also 0, 1 by n is also 0. So 1, here also 1 into x square. So what can you say? By ratio test, the series convergent if x square less than 1, divergent if x square greater than 1, and the test fails when x square is equal to 1. Okay, I'll explain you with one more example. Here also you can omit the first term. We have the general term, the series given by numerator. You can observe first term is 2, second term is 2 into 3, third term is 2 into 3 into 4, third term is up to 4, fourth term is 2, 3, 4, 5. So what will be your general term? 2 into 3 into 4 into up to n plus 1. Denominator 3 into 5 into 7 up to 2n plus 1. Denominator all odd numbers. For the first term, the first odd number, second term 3 into 5, third term 3, 5, 7 and so on into x to the power n. So write down the un plus 1 from this by replacing n by n plus 1. So here you will be having n plus 2, and here when you replace n by n plus 1, this will be 2n plus 3 to the power x to the power n plus 1. Verify this. Now I have written here un plus 1 by un. You can observe 2 into 3 into 4 into up to n plus 1. The terms get cancels with the numerator and the denominator. You are left with n plus 2. Right? Here also 3 into 5 into 7, 2n plus 1. All the terms get cancelled. You are left with 2n plus 3 in the denominator. X to the power n plus 1 by x to the power n. It is only x. Okay. Now find the limit un plus 1 by un. Limit n tending to infinity n plus 2 by 2n plus 3 into x. So if you take n outside, this will be n into 1 plus 2 by n, and denominator n into 2 plus 3 by n into x. So n get cancels. 2 by n, 3 by n becomes 0. So limit of this is 1 by 2 into x or x by 2. So what is your D'Alembert's ratio test? The series is convergent if x by 2 is less than 1 or x is less than 2. Divergent if x by 2 is greater than 1 or x greater than 2. And the test fails if x by 2 is equal to 1 or x is equal to 2.